Let's have a look at this reference design for 50 watts dual output power supply, RDK-1043. It's designed for appliance or industrial or general purpose applications. So this is a single-stage multi-output power supply. We don't have to use any DC to DC post regulators. It can deliver over 90% efficiency at full load condition from end to end. The regulation error on each output is within ±3%, including all of the tolerances. The input here is from 90 to 265 VAC universal input, and the power supply is configured with a 12 volt and 24 volt constant voltage outputs. Let's have a look at the bottom side of the board. The InnoMux2-EP IC sits across the primary and the secondary side of the circuit. A 750 volt PI의 GaN switch is in the IC, and we can deliver zero voltage switching with no additional circuitry. By doing this, the system power loss can be reduced by up to 10%. This IC comes in a thermally efficient install package, and with this package, it can deliver up to 100 watts power. To fully utilize PCB cooling, the source pin of the IC is connected to the copper pore area on the PCB here, and in this way, heat sinks won't be needed anymore. Since this is an evaluation board, the components are actually quite spread out, and this is for testing and measurement purposes. However, for an actual production board, the size of the board would be significantly smaller. Moving on to the secondary side, a very unique thing about this design is that we can use a single winding on the secondary side of the transformer to deliver two different outputs, and each independently regulated. It reduces transformer cost and design complexity. This cannot be achieved with a traditional multi-output flatback. Here we have a synchronous rectifier for higher efficiency, and the control is in the IC. Unlike traditional flatback converters, we use two separate feedbacks. This is to sense and regulate the outputs independently. To initiate energy transfer, a switching cycle request is sent to the primary side via FluxLink. FluxLink is PI's proprietary isolation barrier crossing technology. It eliminates the need for any optocouplers. This reduces the component count and also improves system reliability. This FET here is what we call a selection FET. That's used to steer power only to the output that's requesting it. This is the blocking diode on the 24 volt output, and this is used to make sure that when the selection FET is on, the 24 volt output won't backcharge the 12 volt output. By turning this selection FET on, the power only goes to 12 volt, and by turning it off, the power only goes to 24 volt. And by controlling the selection FET and directing the power flow, we can achieve accurate regulation on all outputs at the same time. As you can see over here, there are no DC to DC post regulators. And this is all thanks to InnoMux2's single-stage power architecture and its precise output regulation capability. This can provide up to a 50% reduction in system component count. For more information about InnoMux2, visit power.com.